In section 8.3, we start trigonometry. Trigonometry is looking at ratios that we find in right triangles based on the fact that if we have similar triangles, we'll always have the same ratio. So if I know that I have the same angles here in these triangles, then if I take A over B, it would always be the same as C over D. So I'm looking at the legs of my two right triangles, which are similar, I will always get the same ratio. Even if I maybe moved my A over here and C here, if I'm looking at the same parts, I'm going to get the same ratio as long as I'm looking at the same angle measure. And this leads us to the ratios of sine, cosine, and tangent. So again, we need to be looking at right triangles. If you don't have a right triangle, then don't try to use trigonometry with it. To solve these problems, the first steps that we want to do is label the hypotenuse. We look where the angle is that we're looking at. This is a Greek letter theta. We just sometimes use that for angles. And I want to look at the side opposite of that. So that'll be my O. So we have the hypotenuse and the opposite. And then next we look for the adjacent side. Adjacent means the side touching it. It's just the side that's left. It's not the hypotenuse, but it is adjacent to that angle. Once we have our triangle labeled like this, using trigonometry should be very easy. We just need to remember which ratio we're using. Sine will always be the opposite side over the hypotenuse. So the sine of theta will be opposite divided by hypotenuse. Cosine will always be the adjacent side over hypotenuse. And tangent will be the opposite over the adjacent. So once we've labeled our triangle like this, it's just a matter of remembering which ratio to use. So memorize these. One way to help us memorize these, students also often remember the name SOHCAHTOA. SOHCAHTOA, sine opposite over hypotenuse, cosine adjacent over hypotenuse, t opposite over adjacent. In this problem, we are asked to express each of these ratios as a fraction and a decimal. So let's do it as a fraction first. Notice in this set we're looking at the angle r, and that's important because looking at the angle r, then, as I label this is my hypotenuse. If we're looking at r, this would be opposite of r, leaving this as the adjacent to r. Our sine we need to remember as opposite over hypotenuse, so we have 4 over 5. Our cosine would be the adjacent over the hypotenuse, so 3 over 5. And our tangent is the opposite side, 4, over the adjacent side, 3. Now when we move over to the s, we need to use a different angle, so we need to start over. Our hypotenuse will still be the same, but now my opposite side is over here at 3 because s is over here, leaving the adjacent side as 4. Notice how this changes our ratios. Now the opposite of s would be 3, but the 5 doesn't change. The cosine would be the 4, adjacent over hypotenuse, and the tangent would be opposite 3 over 4. Notice that these ratios are similar. We're kind of flipping our sine and cosine, but they are different, and we need to be careful that we're looking at the correct angle here. Now they also asked for these as a decimal, so we could write these as 0.8, 0.6, 1.333. Notice that's a repeating decimal. Usually 3 decimals is enough, but a lot of times books will ask for 3 or 4 decimals. When you're doing these, if they have more than 1 decimal, these were easily rounded. They weren't rounded, these are exact numbers. But if they're not, you need to leave a lot of decimals in there, at least 3 decimal places on these ratios. 0.6, 0.8, and 0.75. And one of the reasons we need to leave these ratios is if we're doing this, looking at this table, notice how little these things change from one angle to another. Several of these angles might have a 0.9. So notice that with our decimals, we need to go to about 4 decimal places. It might be hard to read this table, but if you look for just 0.7, for example, that goes all the way from about 43 to maybe 53. Those are all starting with 0.7. So we need to keep some accuracy so that our answer, so we can find the correct angle. In this problem, we have somebody standing on the ground looking up. And the important part is we've already got a right triangle here. What we could be looking, if he's looking up using this silly tool here, he's measuring a 56-degree angle. We want to find the height of the cliff. So if there's a cliff here, he wouldn't be able to measure that very easily, but he could measure maybe to the base of that cliff if it's going straight up. So first, this would be our hypotenuse. our opposite side, our adjacent side. We're looking for the opposite side. We have the adjacent side, so using opposite and adjacent, this must be the tangent. We know our angle is 56. We always put our angle inside of our tan, cosine, or tangent function. We're then looking at opposite over adjacent, which would be x over 97. Then to solve this for x, we multiply both sides by 97. We can plug that into our calculator then, and we should get 143.8. We look at the problem is asking for the height of the cliff to the nearest yard, so we should answer this as 144 yards. Now try putting this into your calculator. See if you're actually getting 144 yards. Because there is a problem that calculators don't always measure angles in degrees. There's different ways to measure angles, so you have to make sure that your settings are correct on your calculator. The best angle to test is just put in the sine of 30 and see if you get 0.5. If you're not getting 0.5 for sine of 30, then your calculator's in the wrong mode. So you need to make sure that you change it back and forth. If you're getting answers that don't make sense, a lot of times that's the reason. Different calculators have different ways to do that, so if you're having trouble, ask me about it. Okay, using inverses, what do we need if we need to find the angle? In this one, we do not know the angle. We just have this ratio here. We want to do this on our calculator. Now, to do the opposite of this, we wouldn't divide by sine because sine's not a number that we can divide by. We want to do the opposite. The opposite is called the inverse. We write it like this. We're saying we're doing the opposite of this. So this is saying, what angle would give me this ratio? Using our calculator, we can just plug it in exactly like this. So let's do that. So in our trig function, make sure you've got the sine inverse. Do not do it by trying to put in your sine and then raising it to a power of -1. That's not going to work. At least it shouldn't work. So make sure you're choosing the inverse sine function. A lot of times it'll just be a shift sign, depending on what your calculator is. Then plug in your ratio. This one is 0.2535 and hit enter. And we end up with 14.6847. And since we're getting 14.68, they often want this to the nearest degree, so we probably round that to 15 degrees. So remember what I said about the number of decimals that we need. So the sine ratio, sine of A, is equal to 4 decimals, but the angle itself, angle A, I rounded it to the nearest degree. Okay, so if we have a problem like this, we want to find the measure of angle x, the nearest degree. So we label hypotenuse, opposite, adjacent. We have the opposite and hypotenuse, we do not have the adjacent. This one would be the sine. The sine of x is 6 over 10, or x is equal to the inverse sine of 6 over 10. We could also simplify the fraction if we like, 3 over 5, but we're just going to plug it into our calculator anyway, and that will give us about 36.8699. We should round that to the nearest degree, 37 degrees. Now we're doing that because they tell us nearest degree here. Okay, for the next one, we're looking for angle x, which is up here. Now I want you to try this on your own. Pause it and see if you can set that up on your own. Okay, and you should have gotten x is equal to 41 degrees.